Great, so this is question 2.7 and it's called intersection. And so for this problem, we're given two singly linked lists and we want to find out where these two lists intersect, and we want to return the intersecting node. So here we have two lists, and the first one goes 1, then 2, 3, 4, and then it goes 7, 8, 9, 10. Then we have a second list which starts at 5, then 6, and it kind of converges at the 7 point where the first list also converge. So then it goes 7, 8, 9, 10. So if we already had all the logic implemented, we would expect it to return the intersecting node of 7, because that's where the two lists converges. So to do this, there's kind of two popular ways of handling it. The first way is that you'd have two pointers, one starting at this list and then the other starting at the first node in this list, and they would just iterate through the list until they reach the end, until they point to null. And when they do, what we want to do is actually be, with each iteration, just be calculating their lengths. And so you would expect at the end to get a length of 8 for the longer one and 6 for the shorter one, because there's 2 then 4. And so their difference is a difference of 2 nodes, because the longer one is just 2 nodes longer than the shorter one. And so you would actually just wait when you reset their pointers, one pointing to the list here and another pointing to the list. You'd actually wait at the shorter end for their difference. So you'd let the pointer at the longer list iterate 2 times, so 1, then 2, then 3. Because it's 2 iterations, 1 to 2, then 2 to 3. And so now you'd actually start iterating them in sequence. So 3, then 4, 5, then 6. And then with the next iteration, you would see that, they're equal to each other, and that you would return that node, which would be the intersecting node. But there is actually a better way to do this. Now, the way I just described would be pretty easy to come up with during an interview. Now, the next approach is a little more optimal, so I'm going to teach this one. But, it's very simple to remember, but it wouldn't really be expected for you to just come up on the spot during the interview. It's a bit of a math problem, and I won't describe any of the math here, but it works because of it. And so when you hit the end of this list, so you would still have these 2 pointers, one pointer here, and then another pointer at the other list. And when this pointer reaches the end of the list, because you're both incrementing them with each iteration, when this one hits the end of the list, you're actually going to reset it to start at the other list, so the start of the other list. And when the pointer that starts at this list hits the end, you actually just reset it to the start of this list. And eventually, just where they happen to converge will be the intersecting node. So you have a pointer starting here and a pointer starting here, and they just kind of hop through here. And then when the shorter list would hit first, so then you'd reset it to the longer list. And when the pointer on the longer list hits the end, you reset it on the shorter list, and then eventually they just happen to converge on the intersecting node here. So I'm going to go ahead and implement this algorithm. So first, we would have a node pointer 1 equal to the start of the first list. Then we have a second pointer, pointer 2, equals to the first node of the second list. And now what we do is we'll have a while loop, and we want to keep going until they're equal to each other. So iterate until pointer 2 and pointer 1 are equal to each other. And when this happens, we just want to return either a pointer, because they're both the same. And through here, we just go, okay, so when pointer 1 reaches the end of the list, so if pointer 2 equals null, because we know it reaches the end of the list, we're just going to reset it to the start of the other list. So pointer 1 is equal to head 2, the head of the second list. Then next, we have the if pointer 2 is null when it reaches its end of the list, then we're just going to reset it to the start of the first list, equals to head 1. And then finally, of course, we have to be iterating these pointers at the same pace. So pointer 1 is equal to pointer1.next. And we're iterating the second pointer by 1 each time as well. Great, so let's go ahead and run this. And yeah, so we reach an intersecting node of 7, which is what was defined above, 7 here. And I forgot to mention, you can just, ignore all this boilerplate code here. This is just me setting up this linked list and, linking them all together. And that just makes use of this simple node class where I define the value stored at the node, as well as a pointer to the next node in the list. So this algorithm has a time complexity of O of n plus m, because we're going to have to iterate through both the longer list and the shorter list. So, this would just you just end up putting, O of n, where n is the longer list. You wouldn't do, the addition here. And so the space complexity is just O of 1. And that's because we're just using the values stored, the values that are provided to us, and we're not using any extra data structures. We're just doing it all in place. So I hope that it helped, and I hope you guys, enjoy the rest of your day. Thank you.